Hi, everyone. Hello. Good morning. Good afternoon. Maybe even good evening, depending on what part of the world you're connecting from today. Hi, hello. As you make your way in out of the waiting room, if you'd please find your way to the chat log and drop a message in there letting us know where in the world you're connecting from today. Is it a good morning? Is it a good afternoon? Or is it a good evening? Where are you? Where in the world are you? My name is Taryn Rimland. I am the Program and Adult Development Manager at Girl Scouts Overseas. It is oh dark 30 for me. I don't know whether to say good morning or not. It's right about 4 a.m. for me here in North Carolina where I'm connecting to all of you from. So we'll go with good morning for me. Hi, hello, good morning. I am so excited to welcome all of you to our Month of the Military Child program today. USA Girl Scouts Overseas is so proud to serve thousands of military children all around the world and really have a chance to celebrate you today. Helping us celebrate today are our friends at Embry Riddle Aeronautical University, and I am happy to introduce you to Rachel Martinez. Rachel works as the Associate Campus Director at ERAU Sigonella in Sicily, Italy, where she has been for about 3.5 years. She lives there with her husband and 3 cats, and she has a Girl Scout on the way. Rachel is expecting soon. She has a baby on the way. In Sicily, she lives near the volcano Mount Etna, where she likes to go hiking. She also spends a lot of time at the beach where she collects seashells. So, Rachel, hi, hello. Thanks for being with us today and kicking off this amazing event.
Thank you so much, Taryn. We are so excited to be here. Yes, as Taryn said, my name is Rachel Martinez. I work here in Sigonella, Sicily for Embry Riddle. We are very excited to see so many young people here that are interested to learn more about STEM, which for those of you who don't know, that's science, technology, engineering, and math. And that includes our topic today, which is asteroids and planetary defense. Parents, thank you so much for encouraging your children to explore these exciting topics and support them in attending this event. As hosts of this event, we just want to share with you a little bit about what we offer. We are located at more than 90 military installations around the world and have been serving our U.S. military personnel and their families in Europe for over 50 years and the Pacific for nearly 10. We are overseas in places like Japan, Italy, Spain, Guam, and many more. Many of you are watching from one of our overseas locations, including some of you that are at the watch parties. In addition to our worldwide presence, Embry-Riddle also has 2 residential campuses in the United States, in Daytona Beach, Florida, and Prescott, Arizona, as well as some civilian campuses in Singapore, Brazil, and Frankfurt. Earlier, I mentioned STEM, science, technology, engineering, and math. And that is a lot of what Embry-Riddle has to offer. You can be a pilot or start your path to becoming an astronaut, or maybe you want to work on planes or become an engineer. Embry-Riddle is who can help you get there. Today, we are so excited to welcome back Dr. Amaya Davis, who's an Embry-Riddle alumna and adjunct faculty for ERU's Department of Aeronautics. She is a U.S. Navy veteran and a supplier quality engineer at Lockheed Martin. We are so excited to have you back, Dr. Davis. She is also a Solar System Ambassador for NASA and has prepared an amazing presentation on asteroids and planetary defense. Thank you for being here, Dr. Davis. You now have the airspace.
Well, thank you so much. Thank you to Embry Riddle and Girl Scouts Overseas. I am so excited to share with you today a little bit of what we're doing at NASA, how are we studying asteroids, and what can we do to defend our planet if there's any coming nearby. So I hope you enjoy the presentation. I'll be asking some questions along the way. Feel free to write in the chat if you want to. Somebody will monitor and let me know. And with that, I'll go ahead and start sharing. Give me 1 second. Okay, 1 second. Sorry. I had to get everything ready. All right. Can everybody see my screen? I hope you do. Okay, so today we are going to be talking about asteroids and planetary defense and what is NASA doing about it. So, when we look at the sky at night, especially at night, I love looking at the sky at night. So pretty, so bright, so beautiful. What exactly do you guys see? What is everything that you see at the night sky? I want to hear, well, I want to see or hear because I'm presented, so I can't see or hear. But what are some of the things that we see? We see the moon, we see stars, we see what else? Maybe comets. So we may see a comet or we may see meteors. Are these meteors meteor showers maybe? Sometimes we have those that come like the Perseids in August. They're beautiful to go and see. Now, what exactly are they? So we see these beautiful, bright shooting stars, right? That we sometimes call it. There's something about it. They are part of either an asteroid or a comet. And I wanted to make a little distinction because sometimes we call them all the same thing. So we have comets. Comets do orbit around our sun, and they're mostly made out of ice. So when they get near the sun, they start to melt, and they kind of have a little bit of gas that comes out of it because of it, and it leaves that beautiful tail that you can see. And then you have asteroids that are kind of like rocks that also orbit our sun, just like our planets do. And sometimes, if either a comet or an asteroid bump into something, a small piece may come off. And that small piece is called a meteoroid. And sometimes either asteroids or meteoroids make it close enough to our planet where if they enter the atmosphere, if they're very, very bright, that's when we can see the streak of light and it's a meteor. And if that meteor actually does make it all the way to Earth, then it's called a meteorite. So now, what exactly are asteroids? So, asteroids nothing more than maybe the beginning of a planet when our solar system was uh, being formed about 4.6 billion years ago, but they never actually did quite make it to form all the way through. Most of them are located in the asteroid belt. So, it is an area in between Mars and Jupiter, the planets, and they just kind of orbit around the sun the same way that our planets do in the solar system. Something cool about asteroids, not only they're just floating rocks orbiting our sun, but some of them have moons that are orbiting them as well. So again, the formation of this, we kind of want to think exactly that when our planet started to form about 4.6 billion years ago, it was just kind of a combination between gases and dust and rocks, and they kind of get together and start getting bigger and bigger and bigger. And some of them end up becoming planets, and some of them never did. And the ones that never did are asteroids. They're kind of like a little bit there, but not quite there. And we find it fascinating to study because it gives us an insight on how planets were formed. And also it gets us understand the different compositions depending on the different stages and how far they made it into becoming or not becoming a planet. But the cool thing about it is they all have different shapes, forms, and they're made out of different materials. And there's a few activities that you guys can do. I sent all the materials to practice. So you can make your own asteroid using different materials and have different shapes. What I like about that one is that you can take a look at some of the asteroid images from NASA and try to make them just like it to see all the different layers that they can have in materials. You can also try to play a little bit of find another asteroid that looks the same, the exact matches, and there's plenty of other activities that I'll let you know at the end where you can find. I wanted to share a few images of some of the asteroids that we are currently studying or we have studied recently. And some of them, as you can see, they have very different shapes, that they're made out of different materials. So we have the Oumuamua. That one, it's very long. It looks like a pen or like a pancake. I want to say like maybe a flat pancake. We have Vesta, Bennu. So Bennu, it's very odd in the composition that it has. And then we have on the top Ida and Dactyl. Dactyl is the tiny moon that you can see next to it. A lot of the names that we use when we are naming either asteroids or different objects in the sky, we like to use names from ancient myths and Greek mythology, Egyptian. They all have a meaning. People used to tell us different stories by looking at the stars and looking at objects, and they like to put names similar to it. So that's where most names actually do come from. Oumuamua actually is a Hawaiian name. Now, how do we know all this about asteroids? We actually do have plenty of missions that have gone out. The first one, really exciting one, was the NASA Galileo mission. This one, it's a telescope that was sent out, but it wasn't sent out to look for asteroids. It just happened to encounter an asteroid during some of the flybys, and that opened the world to science and NASA scientists to start trying to understand a little bit more about it. And this one found Ida and Dactyl, and it was the first time that they saw that asteroids had moons. Before that, before the mission, which actually founded in 1993, scientists did not know that asteroids could have moons. So they found it very interested and decided maybe we should have future missions that study asteroids and get to know a little more about them. But then in 2007, they sent the NASA Dawn mission. And in this mission, it went into the asteroid belt to try to study Vesta. So Vesta and Ceres are two of the largest asteroids that are found in the asteroid belt. And Vesta is so interesting because it has craters and it has kind of like lava flows. And then you're thinking, well, if it's a rock, how can it have lava? Isn't lava coming from volcanoes? And what's fascinating is that we actually do believe it was a baby planet, not necessarily just an asteroid because it never finished. We think it was a baby planet. It just never fully made it to adulthood as a planet. So it did have volcanoes and it had lava flows and it just kind of stopped. And we just think it's really interested. What else? So we also had Oumuamua. Oumuamua was definitely something really cool because it is not from the asteroid belt. It actually doesn't even come from our solar system. Just like the name in Hawaiian says, it is a messenger from far away, a visitor from another star, because we have no idea where it comes from and it doesn't orbit the sun. It just kind of came in, flew by, got near the sun, and left us. And it's gone and it will never come back. It really doesn't have an orbit around us. The shape is so odd, completely different to what we've seen. So, not like a planet formation, maybe kind of round or circular. And the thing about it is that it behaved kind of like a comet when it got near the sun. Because, as I said, comets are made out of like ice, right? And when it gets near the sun, the ice melts and then it releases some gases and it makes it go faster. And it has that beautiful tail that we see with the comets. But it did the same thing, but it didn't have a tail. So nobody knew, and that's when speculators came. Well, that is an alien spacecraft from another universe that comes, but I mean, we don't have a scientific reason, and we love to have it. We don't, but it is not an alien spaceship. Then we had OSIRIS-REx. So this one finished recently. This specific mission, we sent a spacecraft to grab some samples from the asteroid because we wanted to see the actual composition of it. So we sent OSIRIS-REx in 2016, and it went and it did like a very stop, like a short stop and go. So it kind of came very close for under a minute, it had a robotic arm that scooped up a little bit of samples and put it back in the spacecraft, and spacecraft came back to Earth. Not landed, it just kind of came nearby into our orbit, and it dropped a capsule with the samples, and it landed with a parachute that opened, and it landed in Utah in the desert, and we collected and we're studying all the information about it. And we actually learned that it's made out of carbon. It has some ice. It's very dusty. It's like the very, very, very beginning of the accretion when they're forming, that it hasn't gotten very far into the formation process. And we like to study that. And then we also have the Lucy mission. So the Lucy, we are expecting it to get sometime in the near future, right? All the way to between Jupiter. It has the Trojan asteroid. So the Trojan asteroid, think of it as you have Jupiter orbiting the sun, and then you have like a group of asteroids right in front of it and a group right behind it, and they have the exact same orbit. And we find that fascinating. So we decided to send a spaceship just to pick up some samples and get to study and to see what makes Trojan asteroids, because they are definitely different. And the Psyche mission. So the Psyche mission, that one will be arriving in 2029. We launched it recently. It takes a long time to get there. And we're going to go to an asteroid that's made purely of metal. And we believe that it is maybe the core of how a planet would be. So it's a protoplanet. We have the metal cores, and then you have the different layers. And this one, we think it will be very interesting because we cannot study the core of our planet, obviously, but maybe getting samples from this one gives us a lot of insight of what it could be inside of our own planet and the core. Now, all these asteroids sometimes do make it nearby. So what happens if they actually do reach our planet, okay? Well, it depends on the size of it. So we have smaller ones. The smaller ones kind of disintegrate once they enter our atmosphere. So those can be seen like shooting stars or fireballs. Now, fireballs are called when the brightness it is equal to the planet Venus. Then we have meteor-sized ones. The medium ones can leave some pretty big craters, like the example in Arizona that I'm going to show you. And then we can have giant ones, which is very, very rare, and it will happen once in millions and millions of years. And that one can definitely change even the global climate, which is similar to what happened in Chicxulub, in Mexico, the asteroid that caused the mass extinction of the dinosaurs. So this is the meteorite crater in Arizona, the Behringer one, and it's called Behringer after the mining engineer that in the late 1800s, early 1900s kind of said, hey, I don't think this is a volcano eruption hole or a crater. I think this comes from a rock in space, right? So he named it after that. And then this one in particular is the one in the Yucatan Peninsula in Mexico, Chicxulub. This one, it's believed to be the one that caused the mass extinction of the dinosaurs because the impact was so great, so big that it caused huge fires, mega tsunamis, and most likely kind of like a nuclear winter from the impact and all the dust and cloud that came up from it. It made such a dark environment that it blocked the sunlight for months or probably years and kind of caused the end of the Cretaceous period. So that's the theory that most scientists have agreed. That can be pretty devastating. Now, they don't just leave craters. When a meteorite impacts, you can actually see the meteorite. Most of them are very small, like a grain of rice, but you can see some really big ones. This one in particular, the Hoba meteorite, it is the largest meteorite that has ever been found on our planet. It's in Africa, in Namibia, and it's actually a tourist attraction you can go visit. It's pretty heavy. It's like over 10 elephants, about 60 tons, and the size of a car. Something a little closer that you can see would be in New York at the American National Museum of History. And this one is the Cape York meteorite. It's made out of iron, mostly. It's very heavy, about 34 tons. So heavy that if they put it on the floor level at the museum, it will break it and it will collapse. So what they did is they cut up a hole on the actual floor level, as you can see it, and it is supported with columns all the way to the base level so that it won't destroy because of the weight. And you can go touch it and everything's pretty neat. I mean, think if you go and touch it, you're touching something that cannot slam into our planet about 10,000 years ago. So, scary thoughts, huh? Well, let's not worry about it because NASA has a plan. What can we do to protect ourselves if they ever made it close enough? NASA has what they call the NEO observation programs, NEO for Near Earth Objects.
How do we spot near-Earth asteroids? To start, survey telescopes scan the sky. When multiple pictures of the same spot show a speck that's moving, computers automatically check it against a database of known objects. If there's no match, it gets added to a list of objects to confirm. And if it looks like it'll pass very close to us, we give it top priority. Then it's time to call in reinforcements. More astronomers from NASA, other institutions, and even the amateur community submit additional observations. Each new data point helps refine the projected path, and this asteroid is going to fly right on by. All the info will be posted online, so it can continue to be tracked and monitored. Nice work, Planetary Defense Team. Keep watching the skies.
So yes, very cool. We do take a lot of information from our scientists and from our amateur scientists and anybody that's willing to participate. There's websites that you can go and take a look. In this case, I'm going to show you just two. One is the NASA Asteroid Watch, which is NASA Eyes on Asteroids. And this is live. It's a live page where you can go and take a look and click at the asteroid you're interested in. Where is it located within our solar system? How close it is to our planet? And learn more about it. We also have the JPL asteroid tracker, and it will give you the next 5 near objects that are getting close to our planet. And then if you want to know more information on them, you can click. So this is what NASA Eyes on Asteroid looks like. And if we have time, I'd love to show it to you live. And this is the near Earth trajectory of some of the closest approach that we're going to have. It tells you the size, kind of an idea of what, if it's like a building or smaller like an aircraft, how close are they going to be to our planet? And you can click and learn more about it and be better informed. That's using these tools, we were able to track asteroid PT5. So this one, it is kind of cool. We actually think that it's not really an asteroid from the belt, but a small piece of the moon. A long time ago, maybe a huge asteroid kind of smashed into the moon and broke off a small piece of it, and it decided to kind of just float around. And it does have an orbit around the sun. And we know that because we've studied it, and the composition is very similar to that of the composition from the samples that we got from lunar rocks during the Apollo missions when we sent men to the moon back in the late 60s, early 70s, and hopefully next year again. So the cool thing about PT5, so it is small and it's very near in the path to the one that our moon has. Obviously, that's why we also think it is the moon, a piece of the moon. Our gravitational pull last year was so strong that it kind of made it hang around us for about 2 months. And for 2 months, with telescopes and the observatories, we could see 2 moons at the same time. Obviously not as big as our moon, but we did have another object that was just nearby, just hanging around for 2 months until it finally was able to break off our gravitational pull and went back into its orbit in the journey that it's doing. And we are calculating that it will come back to visit us by the year 2055. Then we have a couple of asteroids that we are interested in keeping an eye on because they are large and they're going to be nearby. One of them is Apophis. Apophis will be around our planet in the year 2029, and we should be able to see it with our naked eyes. No telescopes needed. It's going to be pretty close to our path, and we are sending Osiris Apex to investigate it and learn more about it. So Osiris is the same spacecraft that we used to study Bennu and to collect the samples, the ones that we dropped in Utah. So it came, it dropped the samples, and then we decided, hey, maybe you should go and do another mission for us. And we rediverted the path of it, and now it's called Osiris Apex because it's going to study Apophis, and it's an experimental mission. It's going to follow it for 18 months to take pictures, to learn more about it, maybe collect some samples. And then we have the YR4, which I'll talk a little more about that one. But I want you to not be too scared about Apophis. It is going to be nearby, but it's definitely not going to have any impact on our planet.
Asteroid Apophis is set to pass extremely close to Earth in 2029, closer than some of our satellites. Initially, scientists worried about a potential collision when it was discovered in 2004, but recent studies have ruled out an impact in 2029 and beyond. However, the flyby still presents a unique opportunity to learn. Scientists plan to monitor Apophis closely to see how Earth's gravity might alter its path, or even cause asteroid quakes. These observations will help improve our understanding of asteroid dynamics and refine planetary defense strategies. NASA and ESA are planning a mission called Osiris Apex to study Apophis right after its flyby, using what they learned from the successful OSIRIS-REx mission to Bennu. This mission will help us learn how to change the course of hazardous asteroids in the future.
Very, very exciting. And then we have the YR4. This one we expect to have pass our planet and our moon on 2032. And we're still learning a lot about it. So if you hear it in the news, we don't know for sure the correct path. At first, we thought it was going to be near our planet. And by December of last year and January of this year, we calculated that it could be about 2.5% chance of impact on our planet. Well, that has changed by now. It's kind of dropped to 0.28%, which is none. However, now the projected path, we actually think is going to be near our moon, and there has an impact probability with our moon of 3.8%. Again, that may change because we don't have the correct size or understand the correct data. We need multiple telescopes looking and a lot of information to kind of put a model together and determine the correct path. Now, the thing about it, it is pretty big, so it's about the size of a 10-story building, and we decided to send the James Webb Telescope, the one you see in the pictures up there in rotating. This one has some really cool infrared technology that can see through clouds and through different objects. Maybe we can study a little more about it. So we're going to be following with the James Webb Telescope in March of this year, so we can understand a little bit better the actual size of it. Now, if they ever make it close enough to where we're like, this may come too close to our comfort zone, don't worry about it because NASA has the coolest technology demonstrated on how to redirect an asteroid. So we have the DART mission. The DART mission, it was really cool. I actually followed that one from beginning to end, and it's part of the NASA's Planetary Defense. What it means is we have an entire department that works on detecting, tracking, and preventing any potential hazardous impact from either asteroids or comets. Not only we studied where they're located and their orbits and their composition and how fast you're going, but in the event they get too close to us, how can we kind of like bump it out from their trajectory and let them go somewhere else? So we did that with DART. What we wanted to do is to see if we had the capability of doing that. And in 2022, we decided to send that mission to intentionally crash a spacecraft into a moon of an asteroid. Not actually the asteroid. So we had the asteroid Dimorphos that we had been studying, and we thought it was a good example that we could try to test. Instead of trying to get an asteroid out of a specific orbit, because that will be kind of maybe sending it to us, how about if we just change the moon's orbit? And it can still be rotating where it needs to, just maybe change the orbit. So we decided to do that with Didymus, and it was quite successful. It was really exciting. It traveled for about 11 million kilometers at 20,000 kilometers per hour. And it took about 10 months to make it. And we were able to calculate from here how far it had to travel into a moving orbit. And we're talking a moving orbit of Didymus and also the moon going around it. And we were able to impact at the exact location that we wanted it to impact. And we waited until it was closest to us, so it wouldn't take too long. And it still took about 10 months to reach. It had a selfie camera, so we made sure one of the images you saw, it kind of ejected the camera because it recorded it live and it was broadcast. And there's some videos that you can go take a look at it. After the impact, and we have been monitoring the new orbit, and because of the kinetic impact and also a little bit of mass that lost, we have been able to reduce the orbit by 32 minutes. So successful. Yes, we know we can change the course of an asteroid or anything that comes too close for us. What else do we have? So we are going to be working on the NEO Surveyor. NEO Surveyor, it's a new telescope that we're still putting together, and it's going to be launched in 2028. This one will have its only mission is to actually detect asteroids in the future. And it's going to use some of the highest technology we ever had on infrared visibility and different waves that emit a specific type of light that we cannot see, not with our eyes, not with our current telescopes. And we learn all that.
Infrared is a type of light with wavelengths longer than visible light. Infrared is invisible to us, but scientists can build instruments that detect it. Viewing the universe from the infrared perspectives can teach us about the universe's past, present, and future. For example, visible light from baby stars is often hidden behind clouds of gas and dust, but infrared's long wavelengths easily pass through those clouds without being scattered or absorbed. Infrared also allows us to see galaxies that were once invisible, even to the Hubble Space Telescope. Since the Big Bang, the universe has been continually expanding. Visible light emitted by the first galaxies has traveled such great distances that it has been stretched to infrared lengths that the eye can no longer see, but Webb's infrared detectors can. Webb will also peer into the atmospheres of exoplanets, which orbit other stars. When a planet passes in front of its parent star, starlight filters through the planet's atmosphere. Looking at which wavelengths the atmosphere filtered out can reveal its composition and whether a planet might host life. Webb's infrared eyes will reveal a universe like never before.
So that is really exciting. We've learned a lot from the James Webb Telescope and its infrared capabilities, and we are perfecting those infrared capabilities with the NEO Surveyor. So just to let you know, keep an eye on it because in 2028 we'll be launching it and start getting some of the coolest information that we can about potential asteroid that we just can't see because they're hiding behind other planets or clouds or nebula, and our current telescopes are unable to detect it. So Are we okay now? There's going to be asteroids? Yes. Will any reach our planet? Yes. We can see meteor showers at night. Some may actually make it through, and if they do, we are prepared. If they're too big, we'll know what to do right before they make it here. Now, something cool. So, not sponsored by NASA, but this is something I found very educational. You can go to a website that is called NeoFun Asteroid Launcher. And in this case, you can select the type of asteroid that you want to launch into a specific area in our planet. You can pick any that you want. Ooh, I lost my screen. Sorry. Okay, I lost my screen for a second. Okay, so you can launch anywhere that you want to. You can pick a location, and it truly is a lot of fun. Uh, I, st I don't know what I did. I can't move. Sorry. Okay, so how do we know all these signs? When we're talking about craters and images and things like that, we have something very near to us, and that is our beautiful moon. That you see all those dark spots and light spots and little rays, and they are impacts from asteroids or meteoroids. And by studying it from our moon, which is very close, we can learn a whole lot about them, like the position, the size, the impact, the angle that it hit our planet. And by learning all that, we can prepare ourselves better as well. Now, there is a cool activity if you want to try to replicate it, and that is how to make your own craters and learn about it. So there's some materials that you can use, and I have also sent this activity beforehand. And there is a quick video that'll show you how to do it if you want to play along.
Hi, we're here today with a fun and educational activity that you can do at home, at school, or even at a camp. And it involves making craters. Go outside tonight, take a look at the moon, and you'll see these circular features with lines coming out. Those circular features are craters, and the lines coming out are ejecta patterns, rays. The way those craters were formed were from rocks coming from outer space and smashing in to the surface of the moon, pulverizing
What just happened? My video's
the soil there, what we call regolith, and spraying it out along those ejecta pattern rays. You can make your very own craters. You start with about an inch of some flour, spread out nice and smooth, and then take something that is of color, like these are little cake sprinkles, and kind of just sprinkle them evenly over the surface. Then you need another layer, and what we've selected is cocoa. You can sprinkle it with your spoon or sift it over the top, which will make a more even surface. To simulate a rock impacting a surface, drop them from a reasonable height. I'm going to use this big rock first. As you can see, this impactor made a very nice crater. This indentation is the crater. The impactor, the rock, is outside because it actually bounced out. That happens sometimes in real life. And you see that it threw out a bunch of the subsurface material. And we have our own little geologic excavation. The white things coming out, those are the rays, just like you see on the moon. And some of our sprinkles got thrown up, and that represents the mineral diversity of the surface that was impacted. Not all meteorites come in perpendicularly. Sometimes they come in at an angle. Take it and kind of chuck it at an angle. You see that the ejecta pattern is a little bit different. Notice there are no ejecta rays on this side, they're all on that side. From looking at a crater, something we can tell is what sort of angle the impactor came in at. Remember, you can experiment by trying different layers of materials to put down in your pan to impact with different rocks. You can use different size rocks. You can try dropping from different heights or throwing at different angles. And then take a look at your ejecta patterns and see what that tells you about the crater. So have a good time experimenting, and we'll catch you next time.
All right. So I have actually practiced this several times at home. I also do have children. And we tried to record it with our camera and then do the slow motion, and it was very cool to see. Very fascinating. We learned also at sometimes we didn't put enough layers or the correct layers, and we had to try to do that a few times, but I think by now we actually have perfected it, so it is pretty cool. Now, what else? If you like this activity and you want to learn more or practice with different tools that you can do, we have the NASA Space Place website. You can just type that in Google directly and you can change language too. I think you have the option in Spanish, and maybe Google will translate it in different languages. But you can learn everything about Earth, our sun, our solar system. Right now, asteroids is a big topic because we do have those two big ones that I talked about, and you can learn more about them. There's also cool stuff to do. So it's not just about learning, but you can also play different video games that they have been created. They're all educational. They have hands-on activities. They have also competition. So you can see every month they have a different type of competition open to all kids in the US, and even if you're overseas. And then, like the one for last month, it was an art challenge, and they give you all the instructions on what to do. And then anybody can participate and send their work or whatever the project is for that specific month. And then NASA will pick, it has a team of solar system ambassadors, such as myself, who actually review every submission that they have. By the way, there's over 900 of us worldwide. And then we'll review everything that has been submitted, select a few winners, and then NASA will send you a certificate. Sometimes they even encourage that you apply to programs with scholarships. It's really cool, and I want everybody to go ahead and take a look at it. And that's it. That's all I have for now. So I believe I may have a little bit of time just to show you NASA eyes. I'm going to check on my time. I do. So I wanted to show you NASA Eyes. Give me 1 second. Make sure that I have the correct website. So this is the NASA Eyes on asteroids. Now you can have NASA Eyes on the sky, NASA Eyes on Earth, NASA Eyes on the universe. There's different NASA Eyes. We have eyes everywhere. We like to keep an eye on people. But this one is NASA Eyes on Asteroids. You can move around. This is our solar system. You can expand it or you can make it a little bit closer. So we have our sun right here. And then let's take a look at Apophis. Apophis is the one that I said may be reaching in 2029 and will be visible with the naked eye. So you can click right now. So you can see we have Osiris Apex. That's the spacecraft that we're sending to study it. And it's kind of like getting nearby in orbit. But you can click on the specific asteroid that you want, and it will show you an image of what it kind of looks like based on all the telescope pictures that we have taken. You can move it around if you want to take a look at it, and then you can learn a little more about it with the information. So this one was discovered in Arizona by the observatory that's in Arizona. And it tells you the size, diameter, and there's a lot of things that you can learn about it. So again, you can take a look at the spacecraft if you want to see where it is and how is it traveling, what does it do. It's just very simple. Very cool. You can learn a lot about asteroids using that specific site. Now, I wanted to show you eyes on the solar system briefly. And the reason why is because we talked about Oumuamua, the one that came and left and we'll never see again. So Oumuamua, it's already outside of our solar system and it continues to just go by and we'll never see it again. But you can click on it if you want to, and you should be able to get very close to it at some point. I think it's so far away that it won't hardly ever let me get close to it to see it, but it has a very strange shape. Now, we do have some other spacecraft and telescopes traveling out there that can still record where it's located, but eventually we'll never see it again. And last but not least, we have our asteroid launcher site. This is Neil Fan Asteroid Launcher. So you get to pick anywhere you want to in the world if you want. I don't want to hurt anybody in particular, so I'm just going to randomly pick where I'm currently located. How about that? No fun in like no damage intended on anybody. But I am currently located in southern Spain. So I am going to pick southern Spain around this area here. And this is for educational purposes. We are going to select an asteroid similar to Apophis in 2029. What happened if Apophis actually was to make it through our atmosphere and come way too close to us? So Apophis, we think it may be a carbon-based, so we can change it to carbon-based, or you can keep it as an iron one. I mean, you can select the type of material based on the asteroid that you are observing on our NASA ICE tracker. You get to pick the actual diameter if you want, the speed at which it's traveling, and the angle. Again, remember when we did the ejecta pattern experiments, then you can pick an angle. Let's put it at 46, for example, and we're going to go ahead and launch the asteroid and see what happens. Ooh, that's pretty bright. And it gets me a little bit closer. So I actually live over here, so I'm okay. I'm okay. But it'll tell you the size of the crater would be about 10 miles, and the impact force is the equivalent of 84 gigatons of TNT. If you wanted to know how often can we get an impact like that, 758,000 years. So don't worry, we are not having an impact this size in a very long time, and we're keeping an eye on it. You will also be able to learn a little bit about the type of fireball that it's going to do, what kind of damage you can get from a fireball. So it's not just the crater and the impact, but it's a whole lot more that goes behind it. You can also, the shock wave decibel, like the ear, what you hear, the expansion, it's actually pretty devastating. And you get to see the type of it will shake our ground like an earthquake, like a 7.7 magnitude earthquake, and how many people will actually be affected by it. So educational, yes. Can you try it? Try it at home. It's called Neo Fun Asteroid Launcher. And that's it. That's all I have for you guys. I hope you enjoyed my presentation, and if you have any questions, let me know.
Amazing. Thank you so much, Dr. Davis, and thank you to Embry Riddle especially. It is so exciting to see so many of you together at our Embry Riddle campuses. So everyone, if you have any questions for Dr. Davis, we have just a few minutes left with her. Feel free, you can pop them into the chat log, or if you'd like to raise, you can either raise your Zoom hand or your real life hand. I can invite you to unmute to ask. Dr. Davis, while everyone's thinking of questions, I'm curious, do you know when the last time an asteroid hit the planet was?
Yes, and I don't know, I don't remember exactly, but it was within the last couple of years, and it was in Russia. It was actually quite big, and it destroyed a few homes. And that one we did not expect.
Wow, wow. All right, I see some hands going up. I think Ramstein, the Girl Scouts at Ramstein have some questions, and then we'll go to Kelly after that.
Hi, we're here at Ramstein. They were just waving. They wanted to say hi.
Oh, got it. Hi, Ramstein.
Hi, Rhymesign. I am so excited to see so many of you participating. I love it.
Amazing. All right, Kelly. Kelly, tell us where in the world you are, and let's hear your question. Oh no, we can't hear you. It looks like you're unmuted, but Zoom is funky. Sometimes it's like you might be connected to like a headset or something. Let's see. I'm gonna go. Let's see if we can hear the Bahrain Girl Scouts, and Kelly will come back to you. Bahrain, let's see if your audio is cooperating today.
Okay, try it. Go ahead and try it, Eloise.
It is.
Can you
Hello,
hear
we
us?
can hear. We can. Hi.
I wanted to ask why the asteroid that wiped out the dinosaurs isn't called a meteorite when it hit Earth.
You are absolutely correct. It should be called a meteor because it did hit Earth, and theoretically, we should have it somewhere in the ocean, believe it or not. We call it asteroid mostly because of the size of it, but technically, meteor is the correct word. That is fantastic.
Amazing. There's a couple questions in the chat log. When did you know you wanted to study asteroids, and what made you want to study them?
Well, for me as a person, asteroids, it's one of the many things that I do actually study with the NASA Solar System Ambassadors Program. So it's not just it. I did pick this specific program this time, and I've been following asteroids since 2020, when we started putting together the DART mission before it actually did launch, only because I did find it interesting. I stumbled across the program. I thought that it was so cool that NASA was trying to prepare and redirect an asteroid or any kind of object coming. I found it fascinating. I actually mostly work with the moon projects, but this one in particular caught my attention, and ever since I've been learning more and more about it. I participate in many of the different projects with NASA, and the mission specialists get to learn more about it and share it with all of you so we can all be prepared.
Awesome. Okay, let's go back to Kelly's crew and see if audio is cooperating.
Can you hear us now?
There we are. Hi.
I wanted to ask, how does an asteroid move?
Well, asteroids, the majority of them are in that belt, the position like planets. So they orbit because they're being pulled by the sun, kind of, right? So it's like two magnets. Imagine a large magnet and a smaller magnet. So it's like if you have a magnet and you're trying to get a screw, but it's too far to actually stick to it, but it's not far enough to kind of not be there. And as the sun moves around, so do all the planets and the asteroids. They kind of move around in the same way the sun moves around. So that's what it is. Sometimes when they're moving around in the asteroid belt, and they may bump into another one, and those are the ones that kind of like, because of the impulse or the bump from each other, they kind of move out, just like playing pool or billiards, and you hit one of the balls with a stick, and it kind of like veers out of where you're supposed to go, and then it just comes close to us, and that's how they move.
Awesome. Thank you. And it looks like Penelope's group has a question.
Oh, from Aviano.
Hi, Aviano.
Say hi, everybody. All right.
Hello, Aviana.
Hello.
What? Here, Catherine has a question. She's in the junior troop.
What was the first machine you guys ever made? And what was the first idea of why they should have started that company?
How did NASA start? What a great question. I've never thought about that. And what's the first machine NASA built? They're
Okay,
really
so
testing you, Dr. Davis.
they really are. Okay, so I'm going to use some of my very old information that I got, and I'm going to say, so NASA, okay, the first machine per se, the first rockets that NASA built were back in the late 50s, early 60s. So that was before I was born, way before I was born, and when my parents were very young. what they did is, this is a little crazy, but true. What they did is they grabbed missiles, like the ones they use at war, unfortunately, and they decided to modify the missiles to make them into rockets. And they used the same propulsion, which was like gasoline. And on the top, instead of having the missile head, they put a capsule with like very crammed up seats and put astronauts inside to send them to space. That was very crazy. And they did that during the Mercury project. It was one of the very first projects that NASA worked. And NASA was established because back then, there was it was called the space race, and there was a kind of like competition of which country could make it into space for the first time ever before we had any satellites or we had internet or we had cell phones or I mean just they wanted to see what was out there, and it was a competition between what's now Russia. At the time, it was called the USSR and the United States of America. And they decided to put together NASA as part of that as a project to see who could make it first. And from there, now we know a whole lot about our universe in general.
Awesome, very cool. Let's see, I see Zoom user. I think this might, your username is Zoom user, but I think this might be Melina and friend, perhaps in Athens. What do you guys have a question?
Yeah, yeah. Are there any NASA like bases here in Greece? Like stations? Say it loud and for the year?
We heard you. Yeah. Are there any NASA stations or bases or any presence for NASA in Greece? Great question.
It is a great question, and I wish I had an answer for you, but I don't. I really do not know, but I will definitely research it and let you know. I do know that in Spain, they do have a couple of locations. So they have the Mas Palomas Observatory, that's in one of the Canary Islands. And they also have the Center for Investigation and Tourism in Madrid. It's called Robledo de Chavela. And they were used back during the Apollo era, and they are actually being reworked now for the Artemis mission to go back to the moon next year.
Awesome. We'll do, I think we've got time for maybe one more question, and it's a two-part question. Pamela, I believe her group is in Osan, would like to know, first question, why are small asteroids okay to hit the Earth? And my personal favorite question, Dr. Davis, do you think aliens are real?
Okay, let's get to the first one. So, are they okay that they reach our Earth? I mean, if they're very small and they have no damage, considerable damage that we are going to worry about, so something like a small grain of rice or something like a small, piece of rock that you can hold in your hand. I mean, if it hits you, it'll be pretty bad bump at that speed, right? But ideally, we want meteorites to hit Earth in a safe location because we get to collect samples and see the materials, the composition, try to figure out where it came from. It's like a puzzle. So we like having those and seeing those. And actually, there's people that like to collect them as well and purchase them, and it's pretty interesting. So it's a lot closer to get a sample from here and try to figure out where it comes from than trying to send a spacecraft 11 million kilometers away to collect a small sample and bring it back. That's for sure. And cheaper, a lot cheaper for us. Are there aliens out there? That is a fantastic question. So NASA is always going to say no because we don't have any scientific proof that there is anything. But at the same time, we don't have scientific proof there isn't. So we don't know. We are sending telescopes out there to try to explore other solar systems and try to locate new planets that may have all the right conditions to harbor life in the way we see it, so that they have their orbit in the sun, that they're close enough to it, that's not too hot or too cold, that maybe indicate they have water because water is part of the ingredient of life. So we are studying and we're trying to see if we get it. we also have sent many missions to Mars to see and collect samples to see if maybe we can find some kind of like micro level cellular type life to see if it could have happened somewhere outside our planet. But that's as far as we go.
Amazing. I love that answer. We maybe not. Who knows? I love that NASA still is on the quest to figure it out, though. Awesome. Well, thank you so much, everyone, for joining us today. I hope you all, I have to admit, when we scheduled this program, I was hearing stories about the asteroids that might or might not come close to Earth, and I was getting very nervous. But Dr. Davis, you've calmed my fears. I can rest easy to know that the only asteroids will be the ones that our girls launch on the Niels Fund website over the next few days as they play with that really cool tool. So thank you everyone, literally all around the world, for joining us today for celebrating Month of the Military Child, especially to our military children online with us today. Thank you for everything that you do and the sacrifices that you make. And a big, huge thank you to Embry Riddle Aeronautical University. This is one of my favorite partnerships every year. It is always so fun and so exciting for Girl Scouts and Embry Riddle to partner. So to all of our campuses that hosted in-person watch parties, thank you so, so much. Big thank you to Rachel and the rest of the planning team that has worked behind the scenes over the last few months to make this happen. And of course, our hostess with the mostest, Dr. Davis, thank you so much for sharing a little bit of your knowledge and your background and helping us all sleep a little easier that asteroids aren't heading to Earth, at least right now.
It has been my absolute pleasure again. Thank you so much, Girl Scouts overseas, military children around the world, parents, Embry Riddle, as always, alma mater. Just so everybody knows, I did graduate from them with a bachelor's and a master's, and thanks to Embry Riddle, I am where I am right now. So everybody have fun. Thank you for joining today.
We are ending.
Bye. All right, say goodbye.
Thank you.
Bye.